Now let's do a hypothesis test if we have raw data given, the same problem like we did in confidence interval. We have two call centers and we want to test whether the proportion of calls answered within 20 seconds is different or the same for the two call centers. So let's define these parameters exactly like how we defined them in the confidence interval case. Okay, so Y is calls answered within 20 seconds. So proportion of Y calls in two call centers and sample size and sample proportion, and we want to test whether so being equal, if the two proportions are equal, then the difference is 0. That will be our null hypothesis. If they are different, then it will be not equal to. It's a two-tailed test, and let's assume 5% for alpha. Then for center 1 and center 2, we already did all this previously, so we'll do it again. Remember, we need to use count A, call center 1, and it's the same data, so we can use the same name from the previous sheet. Call center 2. Number of Y calls, remember we're going to use count if call center 1, and we want to see whether they are S calls, Y calls. So again, count if call center 2 Y calls, and then P sub 1 is that. And we copy that over, we get P sub 2, P bar sub 2, P bar sub 1, P bar sub 2. And the pooled estimate is you add the two Y calls, that's our numerator, and then divide by the sum of the sample sizes. So you're pooling the two together. So that's our pooled estimate P bar. Okay. And then standard error of estimate then is square root of P bar times 1 minus P bar times 1 over n sub 1 plus 1 over n sub 2, 1 and 2 right brackets. So that's our standard error of estimate. And calculated Z value then is P bar sub 1 minus P bar sub 1 minus P bar sub 2 minus the hypothesized value, and we will go the bracket, so that's our numerator, divided by the standard error of estimate. So this is the calculated Z value. Okay, now we can use the t-table approach or p-value approach. Z table will be norm dot s dot inv, and this is a two-tailed test, so we'll do the right side tail. The probability is 1 minus alpha over 2, so that's our cumulative probability. And this table value is large, so Z calc is less than Z table value, so we cannot reject the null hypothesis. And since this is a two-tailed test, we should really say the absolute value of the Z calc, because it could have been a negative Z value. And if we take the p-value approach, the one-tailed probability is So again, we do norm.s.dist, and since it could be positive or negative, you really need to do the absolute value of z and cumulative. So the absolute value of z puts it on the right side, and when you do, well, you need to really do 1 minus that. So that will give you the tail value. So that's one tail, and this is, there are two tails here. So 2 times that will give you the actual p-value, which is here 64%. So if you concluded that they are different, then the probability of committing type 1 error is 64.2%. So way too high, and that's why we cannot reject the null hypothesis. Okay. Now interpretation is we do not have sufficient evidence to reject, and if we reject it, that would be the probability of type 1 error. So two things, you have to interpret the conclusion and you have to interpret the p-value as well. Okay, so we do not have sufficient evidence to conclude the proportion of calls answered within 20 seconds is different for the two call centers, and if we did conclude that they were different, the probability of type 1 error is 64.24%. So this is 24%.